Hello everyone, welcome to Building Automation System BES training at 308 Colony Street in Winnipeg. And now we are in the generator room. Here is our control panel for the generator room, the transformer, and the control panel for the EMA unit. So what BMS does for the generator room is we monitor the generator status and we control the combustion air damper and the mixed air damper for the generator room. And there is also thermostat. Come over here. So this is the space temperature. BMS is monitoring space temperature in generator room. And then we also have an exhaust fan over there in the corner. That fan stays running all the time. And the combustion air damper will be right above this ductwork. That's our combustion air damper. So every time when there is a fail of normal power, the combustion air damper will open and then generator will start. And this is our relief air damper actuator. That's also exhaust air damper. Those two are the exhaust air damper. And we also have, this is the recirc air damper, and this is our outside air damper. So whenever the generator starts, those damper will start opening to modulate the space temperature to provide the cooling in the room. I think that's everything in the generator room. Right. If the damper doesn't open, we will see damper not open alarm. That means if the BMS is trying to open the damper, but the feedback from the damper is still showing it's closed, we will see the alarm on the BMS. Yes, it will. On the graphic, there will be a box. The background will be red, and it will say it's alarm. And also from the alarm console will show there. The fuel level will be outside. If you come with me, oh, it's gonna be inside here. Yeah, if you come over here, this one. This is the fuel level indicator light. So when fuel level is too high, this light will turn on. Yeah, so the detail will be covered in generator training. And we also have a CO and NO2 sensor in the generator room. We might need to go back to the room. Okay. Yeah, I will show you where they are. We also have two sensors that BMS monitoring in this room. It's the CO sensor right here and the NO2 sensor over there. So what happens is BMS will monitor the CO and NO2 level. There are two stage of alarm levels. The first stage, the outside damper and the exhaust damper will fully open to purge the air in the generator room. That's the first stage. And the second stage there will be audible alarm. If I do a quick test with you, so to do a test for the high level, we press enter, and the password is HA. So HA, and I do enter again. If I go down, go find the test mode. Here is the test mode. If I click OK, test mode, now I press up, say yes. We should also hear that. That's for the second stage level, yeah. And then I can go stop. There we go. Yeah, that's what happens if the CO or NO2 level reach to second stage. And it will also show the alarm in the BMS. And those sensors, they do require annual calibration. So every year you need to do calibrate on those two sensors. Yeah, we can do calibration as well, yeah. Yes, we can set up the email alarm for you. So we can pick some critical alarm. Let's say, for example, some room space temperature that's we consider as non-critical alarm, right? That doesn't need to go through your email or your phone. And we can pick up some critical alarm and set up the email alarm. And anytime the alarm triggers, the BMS will send the alarm to you. Okay. But that will require the internet access to our JIS panel in the penthouse. Okay. Yeah. As of now, all the controller and BMS, they are in the local network. Okay. So we will have to work with your IT to give us the internet access to the JIS in the penthouse. Yeah. Yeah, I will show you our JIS. Yeah, later when we get in the penthouse. No, it doesn't go to fire panel. It's a local. Okay. It's just right here. Yeah. Here? Yeah. In the room and outside. Yeah. I go to a bike room. No, I got it. It's okay. Thank you. Yeah, I'm good. Now we are in the bike room. What do we have for the BMS? We have our control panel. right here. And there's a sump pit. We are also monitoring. BMS monitors the high level and the sump pit fault alarm. And here is the MUA for the laundry room. And this is outside air coming in and then goes to the electric heater. There's an electric heater and the fan. And there's a gas burner. And then it discharges to the laundry room. And we have outside damper over there. And then there's a filter pressure sensor that tells you the filter status when is the time to replace the sensor. And then we have our supplier temperature sensor and the supplier pressure sensor over here, just above this ductwork. And at the discharge, it splits to two ductwork. That's one of the discharge. And we have a supplier actuator over there. And then the other one goes the other side. And we also have another supplier damper with actuator. So this MUA only turns on when dryer is on. So BMS monitors the dryer status in two rooms, one on the west side, the other one on the east side, I believe. Yeah, so BMS only turns on the MUA when dryer is on. And then the damper, BMS also monitors the mixer damper. The mixer damper modulates to maintain the space at nature pressure. Yeah, do you have any question for the MUA? Yeah. So we have a two space temperature in the laundry room. So it doesn't have winter mode or summer mode. It just runs. Well, what happens is the BMS monitors those two stats, and we also have a set point for those thermostat. And make carrier unit turns on to maintain the supplier temperature. That supplier temperature set point will reset based on the space temperature and set point. Let's say if the space temperature is lower than the set point, supplier temperature set point will go up. And then make carrier unit will turn on the electric heater to maintain supplier temperature. So if needed, it will turn on the gas burner. But the electric heater will be acting as a first heating stage. It's under BMS, BMS, yes. Yes, you are able to change the space temperature set point. You are also able to override supplier temperature set point. It's in inch water column, yeah. Normally, I would do 120 Pascal. 120, okay. Pascal, that's 0.5 inch water column. Okay, so 0.5, 0.5, yeah. Okay. Yeah. But that filter alarm, it measures the filter differential pressure only when MUA is running, right? Yeah. If that is not running, the differential pressure will just be 0. You may not see it. So you will see that the filter alarm when MUA is running. Yeah. And the other thing I would like to be specific is this MUA has a bypass damper. So what happens is the fan speed is a fixed speed. It's not on the VFD. The speed is not modulating. It's just a fixed speed. Whenever the space pressure goes too much, the bypass damper will open. The discharge damper will close. So it's just doing the research in the unit, inside the unit. Yeah. Yes, on the BMS, you will see what's the damper position for the bypass damper. Yeah, you will be able to see the outside temperature coming into the unit, and also the supplier temperature after the electric heater, and also the supplier temperature after the gas burner. Okay. Yes. Thank you. Yeah. We can go to garbage room and then electrical room. Hello everyone, welcome to garbage room. The BMS is monitoring the space temperature for the room, and we also control the exhaust fan and the damper. We also monitor the sump pit in the garbage room. And the secret for the exhaust fan is the exhaust fan stays running the whole time, unless the outside temperature drop below 5 degrees set point, and that set point is adjustable. And that's the actuator, that's the exhaust fan. Actuator has to be verified open before we turn on the fan. For this room, we only monitor the space temperature and no space pressure, and turn on the exhaust fan. Yeah, it would be nice to have it. Yeah. Yes, this is a sump pit. That's right. Only 2 sump pit. And unit heater is a standalone. It has its own thermostat at the back. Okay. It turns on whenever needed. It's running all the time in the summer. In the summer, yeah. So once the temperature is below 5 degrees in the winter, it turns off. This will be the temperature in this room, just for monitoring. Yeah, yeah. It doesn't control the temperature. Hello, everyone. Welcome to electrical room. The BMS has a control panel, which is in that far corner over there. This is our control panel, and we also have a 2 standalone heat pump stat. This is one of them, heat pump number 2. And heat pump number 1 stat is just on the wall over there. If you look above, that will be our heat pump. Heat pump number 1, heat pump number 2. And the BMS controls the heat pump loop. So the condensing side of the heat pump loop. So the pump will be over there. That's pump 28. That's pump 28. And the disconnect is over there. We also have 4 isolation valve on the pipe. So that's those 4 pipe. Each pipe will have its own isolation valve. So 2 pipe. So that's hot side supply, hot side return, cold side supply, cold side return. And then we also have a 3-way valve to modulate the temperature. What we do is when heat pump is running in the winter season, it provides the heat to the room, and the other side of the heat pump will be cold. It will require heat, and then we will open the heating pipe isolation valve, and the pump will turn on. The 3-way valve will modulate to maintain the loop temperature at 30 degrees C. And in the summertime, it reverts the other way. Heat pump does the cooling to the room, and the heat pump condensing side will be hot, and it requires cooling. When it requires cooling, the heating pipe isolation valve will be closed. The cooling isolation valve will open, and then the pump will be running. 3-way valve will modulate to maintain the loop temperature at 30 degrees. The breaker for our control panel, I believe it's labeled E129. I think it should be in the, yes, I believe every control panel should have a label which breaker, where the power is fed. No, the BMS doesn't monitor the heat pump. It monitors the loop temperature.
Is it loop temperature?
Only the loop. We will make sure the loop temperature is maintained at 30 degrees C in the summer and in the winter, because that is the temperature. So that temperature has to stay in that range so the heat pump will work properly. And you will also see the loop temperature on the supply and on the return. Yes, it will. Most likely it will, but the heat pump will just be under performance if that loop temperature.
Underperformance.
Yes,
Okay.
if that loop temperature isn't maintained well. Yes, you can see loop temperature, and we also have a trend set up. You can see the loop temperature for past 2 weeks.
Okay. Are you teaching us that
Yes.
today? Okay, that's
Yes.
great. Okay.
Yeah. So this heat pump does the heating or does the cooling. The loop water, it's mixed. In the summer, it will be cold water. In the winter, it will be hot water. So each loop will have isolation valve. If you look over there, there's an actuator. So in the summer, it requires the cooling. So the heating pipe isolation valve will be closed.
Yeah.
The cooling side will open. And yes, once we go to the BMS, once we look at the graphic, we will go detail on the sequence of operation.
Oh, all right.
Yeah, so right now I'm just showing you the location pretty much. Welcome to the parkade. The BMS controls the 4 electric makeup unit for the soffit area. It will be this access, those 4 big access door, 1, 2, 3, 4. I believe the number will be EMA 1, 2, 3, 4. And we have a space temperature in the soffit area. So EMA 1 and 2, they share 1 space temperature. EMA 3, 4, they share 1 space temperature. So 4 unit, 2 space temperature. It's all open. It's all open, yeah. It's just pretty wide. That's why they put 4 units.
Oh.
Yes. No, not to increase the temp. You can change the space temperature set point for the soffit.
Space temperature.
Yeah, but you couldn't adjust the heating demand, right? For the electric heater. Yeah, that's the fixed number.
Okay.
Yeah, it just stays
Space
there.
temperature, I can-
Yeah. So as long as the temperature drop below the set point, it will turn on right away. Yeah. There is an offset Yeah, but as long the space temperature drop below set point, it will turn on. No.
Just to be safe.
To turn the disconnect, it's a good habit to have it turned off in the summer because we don't need them anyways. Just we have to make sure it turns on before it turns on. Okay, welcome to first floor lobby. So we have stairwell pressurization fan 5, just above ceiling right here. So that fan will stay running the whole time regardless. BMS commands the fan and monitor the status of the fan. And if you step into the office, we have DDC fan coil unit. This is the fan coil unit number 5. This is our space temperature. And the fan coil unit will be right here above the ceiling. It has BMS controls the space temperature, and we control the heating valve, cooling valve, and the fan enable. We also monitor the fan status and the supply air temperature. Yes, the space temperature sensor is here. The space temperature set point can be controlled by the BMS, and the space temperature is also monitored by the BMS. You can also see the heating, cooling valve position, and the fan enable, fan status, and the discharge air temperature of the fan coil unit. Yeah, it's gonna be the same loop.
Same loop. Right?
Same loop. So one loop for the heating, one loop for the cooling. Yes, yes. Yeah. If you look at the graphic, it will be much clearer.
Clear.
Yeah, the layout of the piping. Yes, that will be a common area fan coil unit. Fan coil unit 1, 2, 3, 4, 5, 6, 7. This is number 5. Yes, so BMS does have a floor plan for the first floor, second floor. From the floor plan, you can easily tell each fan coil unit location. Yeah, the location of each fan. Yeah. So fan coil unit 5, 6, 7, they are on the first floor. 1, 2, 3, 4, they are on the second floor.
Okay.
Yeah. And the other thing I would like to show you is the HRV1. So HRV1 does this data room and also the washroom over here. This is the location of HRV1. It's next to the office on the first floor. The unit is right there. The BMS has a command for HRV1 and also the HRV1 status. It also monitors the exhaust, outside air damper, and the exhaust air damper. So apparently the exhaust air damper and the outside air damper has to be proved open by end switch, then the HRV1 will turn on. Not for HRV1 because HRV1 stays running the whole time. But HRV2 and HRV3, they will have a timer. I can show you the location for those dampers. That will be HRV1 fresh air damper and the electric heater. That's the fresh air damper for the HRV1. You see the orange actuator? Yeah. And with electric heater and the exhaust damper. That breaker is for electric heater.
Electric heater.
For electric heater, yeah. Yeah, that's the electric heater. If you do ever experience the BMS is trying to start the HRV, but we don't see the HRV status, first issue we will check is the breaker, the disconnect for HRV. The second thing, it could be the damper. If those damper are not 100% open, the HRV won't turn on because the exhaust damper and switch and the fresh air damper and switch, they are wired in series with HRV1 command. So those damper has to be proved open in order to start the fan. No, damper position is not.
No.
Yeah, so we already set it to like 85%. Whenever damper opens 85%, the end switch will close.
Okay.
Yes, if we are trying to turn on the HRV, but we don't see HRV status. So on the BMS, we will see HRV not on alarm. So that will be manually disable the HRV. So if the outside air quality is bad,
Yeah.
we will have to manually disable HRV. Not for the lobby, but for the office.
Just for this one.
For the office, yeah. We also have EMA number 6 located. The unit is above the ceiling right here, but it actually serves the soffit area outside in here. If you are looking for the thermostat, it's right above us, above the door. If you pop off that ceiling tile, you will see a thermostat. That's the space temperature we are monitoring. And yeah, electric makeup air unit. That's number 6. that this solve it. Same idea with EMA 1234. Yeah, it's just the location. Here we are on the first floor south side of the building on the main floor, and we've got our fan coil unit number 6. The control panel is ready to be set the unit, and this is our thermostat for the fan coil unit 6. It will be good. It's a good time to look at those units because right now it's pretty open. You can see that's our heating valve and the cooling valve. The BMS tag is also on the wire. And for fan coil unit 6, we have a BTU meter. So 1 BTU meter on the supply on the hot water side, 1 BTU meter on the cold side. So it measures the flow rate, and also the energy used for the loop.
Okay.
Yeah, you can see that on the BMS. Those are BTU meter. That one is not being used. That's why we are not using that. That's the remote sensor. We are not using the remote sensor. It comes with the package, but we are not using that. we already have other like internal sensor being installed already. Yeah. So that's our DDC thermostat.
Yeah.
We monitor the space temperature and we can adjust the set point
Through BMS.
through the BMS. And the BMS will open and close the heating valve, cooling valve, and turn on the fan based on the space temperature demand. Yeah, if it's called for heating valve opens, fan turns on. If it's called for cooling valve opens and turns on the fan. We'll also monitor the discharger temperature of this fan coil unit. Yeah. Yes and no, because like the suite, those suites are standalone. So DDC doesn't monitor the space temperature, doesn't see the valve position. But for those DDC fan coil unit, DDC has a full control of the unit. Yeah. What I mean full control is it has the command, monitor the status, and the heating, cooling valve position, and also space temperature and set point. If it ever happens, you will see it on the BMS because BMS monitors the valve position. Yeah, but I don't think it's going to happen because based on the space demand, if it's called for heating, only heating valve opens. If it's called for cooling, only cooling valve opens. Yeah, only one valve. Yes. If that's why we have a discharger temperature sensor. So let's say in the winter time, which we are calling for heat, the heating valve should be open and the discharger temperature should be up. If we see discharger temperature is still too low, around 20-ish C, we know the heating valve didn't open for some reason. Yeah, valve could be failed or the power. Or
it doesn't show us exactly.
Yes, you will know based on the valve position and the supplier temperature. Yeah, it wouldn't tell you the actuator stack open or stack close.
Yeah, we can check it one.
Yes.
Okay.
No, and for the filter maintenance, I think it will be covered during mechanical. Yeah, I think it's a 3 month. If you come closer, this is HRV2, the timer for the HRV2. The HRV2 is also standalone unit. It's not monitored by the BMS. If you remove the cover, it tells you the time. You can manually turn this by pressing the manual button, and also you can also do the clock. So let me do this. If I manually turns on the HRV1 won't open. The fan won't start until the damper fully opens. I can show you where the dampers are. That's one of the damper. This is the other one. This will be the fresh air, outside damper with the electric heater. And that's our exhaust damper. See, the HRV1 is still not, because it's waiting for the actuator. It's waiting for the damper to fully open. Now it turns on because the damper fully opened. So HRV2 and HRV1, they are the same unit, just different control. HRV2 and HRV3 controlled by the timer, the standalone unit, but HRV1 is controlled by DDC because HRV1 shall be running the whole time to reject the heat in data room. And then I will show you the location for fan coil 7 and the HRV3. They are the same unit, just show you the location. On the north side of the main floor, we have fan coil unit number 7 and also HRV number 3. They are exactly the same unit with fan coil 6 and HRV2. And here's our unit for fan coil unit 7 and the control panel. The thermostat is just behind the wall. Right here, we have the label fan coil unit 7, space temperature. And it also, the fan coil unit 7 also has a BTU meter. Same idea with the fan coil unit 6. One for the cooling side, the other one for the heating side. It monitors the flow and also the energy used. It also records the last year total energy being used. And all those information you can see on the BMS. Hello everyone, welcome to laundry room. So we have 8 washing machine and the dryer on that side and the other 16 on this side. The BMS monitors the laundry status. So on the BMS, you will see two space dryer status. So this is one of them, this is the other one. So when any of, the first one is called Planium 1 dryer status, that's for this side. The Planium number 2 dryer status, that's on this side. So when any of those dryer is running, the BMS will see the Planium 2 dryer status. If any of those dryer is on, the BMS will see Planium 1 dryer status is on. So when any dryer is running, the makeup air unit will start. And here, let me show you the pressure sensor, because that's the main purpose of the makeup air unit. This will be the discharge. The air will be coming from the makeup air unit, and then BMS monitors the space pressure and also monitors the space temperature. Yeah, so this pressure has to be around 0 Pascal for makeup air unit to make up the air being exhausted by dryer. Yeah, that's for the Planium number 1. I will show you Planium number 2. Yes, you are able to manually change it. If you want a slightly positive pressure, you can change it to 0.1.
Oh, okay.
Yeah, and this is the Planium number 2. Here, the ductwork is a little bit smaller because we have less dryer in this area. So here will be Planium 2 pressure sensor, Planium 2 space temperature. And our pressure sensor is also there. If you want, with a display, you can easily tell what is the space pressure. Yes, that will be for the space temperature over there and here.
Okay.
Yes. The BMS takes the average of those two temperatures. Yes. Yeah. Yeah, because there are 2 sensor.
Okay.
Takes the average. No, just based on the side. The dryer on this side or the dryer on this side. Just, yeah. That's right.
Okay.
That's right. Yeah. Yeah, but any dryer is running, the makeup air unit will turn on. And in this room, we have 2 fan coil units. It's a DDC fan coil unit. It doesn't have any fresh air. It just does the recirculate to the room. Here is space temperature for fan coil unit number 3. The unit is right here for fan coil unit 3, and DDC control panel is next to the unit. And the fan coil unit 4 is here. Fan coil unit 4 is here. And the space temperature sensor is next to the door with the label, fan coil 4, space temperature.
So this can all be adjusted to the BMS?
Yes, all those DDC fan coil units are identical. They are all the same, yes.
Okay.
Yeah, and I will show you where is the number 1, number 2. If we walk across the hallway in amenity room, we have fan coil unit number 1, number 2. This is the thermostat for fan coil number 2. It's labeled fan coil 2. The unit will be in here. The fan coil unit will be above this ceiling tile. And this is the thermostat for fan coil unit number 1. The unit will be right here. If you pop up this ceiling tile, you will see the unit. The DDC control panel is also next to the unit. So let's go to 6th floor. Hello everyone, welcome to Suite 607. So we have a Honeywell standalone thermostat for the Suite fan coil unit. They are all standalone units, they are not tied to DDC, and I will show you how to configure those thermostats. Mode, we have 3 modes: heating mode, cooling mode, or off. And that's for the mode. And for the fan, we have a fan auto, fan on, and the fan recircuit. So the mode off means fan is off, everything is off. The heating valve, cooling valve is all off. If it's in heating mode, that means it's only in heating mode. If the space temperature is less than the set point, the heating valve will open and then the fan will start. Fan auto, it means fan only turns on when there is a call for heat. If there's no call for heat or the room temperature is satisfied, the fan will be turned off and the heating valve will close as well. Fan on means fan is running the whole time, regardless if there is a call for heating or a call for cooling. So now we are in the heating mode with the fan on. It means the fan is running, and if there's a call for heat, the heating valve will open. If there's no call for heat, the heating valve will close. Fan recirc, it's similar with the fan. It means the fan is just in the recirculation mode. If there's a call for heating, heating valve turns on. If there's no call for heating, heating valve.
Recirculation.
Fan recirculation, yeah. Okay. But we would suggest do fan auto or fan on. So fan recirculation, in fan recirculation mode, it will only do the recirculation. It wouldn't do the heating or cooling mode.
There's no call for
yes, there's no call for heating or no for cooling. Yes, the maximum set point is 25 degrees C, and the minimum set point is 18 degrees C. You can change the set point on here just by pressing plus or minus if you want to lower the set point. Maximum.
25.
Yes, you are able to do it. I just need to refresh my mind a little bit. Yes, so there it's okay. There we go. So I think you need to press the center, the menu button, and then press plus. Oops. Then we are in the programs. We are in the program setting. So you can do select. You can program the time. Well, it will be the trick, right? The tenant they will only know adjusting the set point, and to go access the program, we have to press this button, and then we have to do this. The tenant wouldn't know that.
That's the sequence. Okay.
Yeah. Yes. Okay. And to answer your question, so there is a temporary hold or permanent hold for the set point. So once you adjust the set point, let's see if I increase it to 23, here it's a temporary hold, right? Mm-hmm. And you press this button, it tells you, okay, permanent hold. So this set point is gonna stay there permanently, not temporarily. It's 4 hours.
4 hours?
Yes.
Oh, okay.
Yeah. If they want to lower 21, here it's at permanent hold. Right now it's already in permanent hold mode, right? Mm-hmm. So we only need to adjust the set point, and it's already permanent hold automatically.
Okay.
So
how does it go to temporary mode again?
So if you just adjust the set point,
okay,
and here it will show it's a permanent hold. Mm-hmm. Then if you press this button, this one, hold, temporary hold, or permanent hold. Happen. Yeah, so you may just want permanent
just
hold.
To remove it.
Yeah, no problem. So if you want to go to the program menu, hold the menu button, press plus, hold. If I go next, program. Here I press select, off. Okay, just go select. This one tells you this is how you program your schedule. So here it's a Monday to Friday, 6 a.m. We want this temperature. We want 21 because we just wake up, right? Then we'll press again to change the time again. We can change the time setting and then press this again. So at the 6 a.m., we just wake up. Monday to Friday, we want 21 degrees and in heating. And then in the cooling, what is the set point we want for the cooling? And then what time we leave home, right, away. And if we go select, so we want to enable this function. So then we go next. What time? We can change the time. Then we can also change the heating set point, cooling set point. And now it tells you what time we come back home again. Right? This is the home mode. We turn it on. Then we can change the time, change the heating set point, change the cooling set point. And what time do we go to bed? Sleep mode. We turn it on, we turn on the function and the time. What time do we go to bed? And the heating set point. And then the next one is on the weekend. Saturday, same thing. What time we wake up, and the set point for heating, cooling. What time we come back home, what time we leave home. That's how we program the schedule. There are 5 mode away week. away, home, and sleep. Yeah, so that's for the schedule. After changing that, it will say save. And I believe there is another, the installation guide will allow us to access the higher level of changing the set point. For example, what's the minimum set point? What's the maximum set point? Right now it's 25 and 18. If you want to increase that to 28, I will have to send you the menu. You can go over the menu. That tells you. It tells you like which parameter, what it means, and what are the range, what are the setting you will be doing. Yeah, it will be super detailed.
Oh,
yeah. And as of now, we already programmed this thermostat as per spec. Yeah. So you can always make some adjustment as per customer. Yes, there is a reset. It will be included in that menu. Just from top of my head, I don't I don't remember all those parameters. Yes, but let me grab your email address. I will forward you the menu. Yeah, we can remove that because in the program here it will say it's on or off, right? You can just turn it off. Yeah, so it's not running based on the schedule.
So basically, we don't really program the thermostat per se. Like we don't put it on the schedule. So when tenants come in, it's as is. So we have a maximum of 18 and 25. This is they just play around with the temperature. The problem is at times when they are here, suddenly go into programming mode or whatever. They're playing around with their thermostat. So that's why we're asking on how to go back to its original programming, or if in case that happens, what we need to press.
No, there was no lock mode because this is a standalone unit, right? So anyone, could be me or it could be Thailand, or it could be even manufacturer. When they come here, they will have to play with those 5 buttons in order to go to the configuration mode. But like I said, that is a trick. Nobody would know you have to press this one and then press this one. So what I can do, I will send you the user manual for the stat, and then I will also share with you the settings, all the settings, how we configured those thermostat. Every parameter we made the change on, and we will share that information to you as well. Hello everyone, welcome to the premium suite. The Fanco unit for every suite, they are the same. The only difference will be the thermostat. In the premium suite, we have an Ecobee thermostat. It monitors space temperature, the space humidity. Here is how we adjust the set point. We just press this set point button. We can just go, let's say 22. Hit it again. It's automatically saved. And then we can press up right corner here to change the system mode. It has a heating mode, cooling mode, auto mode, or off. It's same with the thermostat, Honeywell thermostat. It has a heating, cooling, and off, but this one, it has an auto mode. And then here, a comfort setting, you can set it to we are home, or we are away, or we are sleeping. It's kind of like the schedule we did for the other room. And then, go to next, fan mode. Fan mode will have auto mode or mode. Mode means the fan will be running the whole time. Auto mode means fan only turns on when there's a call for heating or call for cooling. Here it tells you what's the sensor rating. Here, we can also change the schedule on the Ecobee stat. Press the schedule. It tells you, okay, Monday, what time do we sleep? What time we wake up? What time we sleep again? We can also add, if we press this add button, we can add we are home or we are away or we sleep. If I say away, then I change Monday, 8 a.m. I leave for work. Now I add that away on here. You can also remove the schedule by clicking that and press this delete button. Do you want to delete? You will see yes. Yeah, and also you can copy it to copy the same schedule from Monday to Friday. I will say save. Everything was saved. And then let's see what is the alarm. Furnace maintenance.
It reminds you time to change your furnace filter. So it also reminds you based on the runtime of the unit, it will remind you to change the filter of the furnace.
Okay.
Yeah, if filter gets changed, you press here. If not, remind me later. Yeah, it also record when was the last time filter change. Based on the runtime. Yeah, based on the runtime will be how many days. Yeah. Yeah. So in the heating mode, the set point will be heating set point. And in the cooling mode, the set point will be the cooling set point. Heating set point and cooling set point are different. And then if it's in auto mode, it's automatically, you can change, let's say, cooling set point, I want to be 24. And heating set point, I want to be 21. You can, it's switch heating cooling mode automatically. Yeah. Here it also has, for example, right now I'm in auto mode. I'm changing the cooling set point, let's say, to 23. I hit yes. Now it's a temporary change. This will only, the setting will revert back at 11:30. If I press this one, it's a temporary change. Could I get back to you for the permanent set point change? Yeah. Yeah. I will write that down. I owe you this one. Hello, everyone. Welcome to the penthouse roof. Now we are looking at the ERV unit. This ERV does the fresh air to the building, and it has the internal panel. This is the internal controller, and this will be the BMS signal. So BMS does the command, ERV command, heat recovery mode, or recirculation mode enable. We also pick up the damper alarm, low limit. This is the BMS tag and the ERV internal panel. So right now we are in the heat recovery mode. Those dampers should switch every 60 seconds. So if it's in free cooling mode, they switch every 3 hours. See, it does the switch. If any damper is stuck or end switch didn't make, the unit will be turned off, and we will have the damper alarm. It will show on the BMS. And this is the schematic drawing of the unit. So this is the filter. The BMS monitors the filter differential pressure. Yeah, because the unit is running, the pressure sensor and the filter. And now the BMS, this is the supply fan. And inside here, we will have a low limit sensor, a supply air temperature. Yeah, I think that's it for the outside. Oh, here, right? This one does not have heat. It's, what do you call that?
It's not heated?
It's not electric heater, not burner. It's a heating coil.
Oh.
So here is the coil of the unit, supply and the return. This coil can do heating or cooling. So in the winter, it does the heating. In the summer, it does the cooling. So same thing, it will, just like the makeup air unit downstairs, not the makeup air unit. So it's like a heat pump loop.
Exactly, yeah.
Yeah, it will have a cooling side isolation valve and the heating side isolation valve. Depending on the heating season or cooling season, they will be switching. Yes, this is also a part of building loop. So right now, it's in the winter. This is our heating, and it's fed off the heating loop, building heating loop. Yeah, same loop. Yes,
Okay.
yeah. And this is the disconnect of the HRV. One loop, yes. I will show you where they separated heating loop and the cooling loop inside. I will show you. They have the manual valve if you want to do some sort of maintenance, but all the isolation valves are also controlled by the BMS. You can also close
maybe
and
it's like for
yeah.
question,
Yeah.
sorry.
Okay, I think that's any question for the HRV outside.
The
So
controller. It's
you
all
can
safety.
you can turn it off through the BMS.
Through the-
So the BMS just click off. It's a pretty simple
through
one.
BMS
Yeah.
is safer way.
Yes, it's a safer way because they do have isolation damper.
Oh.
They do have a damper on the discharge side and on the return side. They have isolation damper. We have to make sure those damper fully open before we start the fan. We have the sensor for supply air for sure, and also the discharge, the return, discharge return humidity. Outside air temperature will not be from this unit. We'll be building outside air temperature. Yeah, I can show you that later once we get there. Yes, we pick up the smoke alarm from the fire alarm panel. Yeah, so if fire alarm sees any smoke condition, it will send to BMS. BMS will turn it off. Yeah, I show them the filter.
To change it.
Yes, you just open this. Yeah, you just no, just winter, just one filter. Yeah, the roof that's just a solar. That's for solar. It's okay. But I can show you the heat air source heat pump because we're already here. Hello everyone, welcome to the air source heat pump. We have in total of 5 units air source heat pump. So air source heat pump, I would say number 1, number 2, but air source heat pump number 1, it has a 4 unit. So air source heat pump 1 can only do heating at the time, can only do the heating mode, or it can only do the cooling mode. But air source heat pump 2 can do heating mode and cooling mode at the same time. So that's our air source heat pump 1A. This is air source heat pump 1A, air source heat pump 1B, air source heat pump 1C, and air source heat pump 1D. And this bigger unit, air source heat pump 2, that can do heating mode and cooling mode at the same time. This is air source heat pump 2. And the disconnect for air source heat pump 2, disconnect for air source heat pump 1B, 1C, 1D, they are all labeled with lemon cone. Yes, yes. So as of now, air source heat pump 1A, 1B, 1C, 1D, they are being turned on and off together at the same time, doing the heating mode and cooling mode together. One set point, yeah. Through the BMS, yes. But for maintenance, we would recommend to turn them off through the BMS because it will start and close like properly because there is a isolation valve associated with those units, right?
Yeah.
So it's better to turn them off through the BMS. And if you are actually doing the maintenance, make sure the disconnect is off as well. Because the BMS, it could be multiple people accessing it, right?
Yeah.
If I'm looking at the BMS on the roof, yeah, for safety.
Breaker, sure.
Yeah, the breaker. So right now, it's in the winter. The air source heat pump 1A, 1B, 1C, 1D, they are in the heating mode. And they are in the primary loop of the building primary loop. Yeah. So right now, they supply the heat to the storage tank 1, and the storage tank 2. Storage tank 1, 2. So, and then there is a pump, will transfer the heat to heat exchanger. Well, once we look at the graphic, it will be much easier to understand. So for the HRV, as we mentioned earlier, there's only one coil that does the heating and the cooling. This will be the loop for the coil. And see, this loop can fed from here, or it can be fed from here. So this is our cooling loop. So right now, the isolation valve of the cooling loop are closed because it's in the winter, it's doing the heating. So the flow is fed by this loop, which is from the heating side. So right now, flow goes this way and goes out and come back, go this way. It doesn't go to the cooling side. Then if we come a little bit, if we come to that side, this is HRV heating isolation valve. It's right here. Right now, this valve, both valves are open. That's on the supply. This is on the return. And the flow is fed by this pump. Right now, the pump is running. And the heat is coming from this heat exchanger. I believe this is heat exchanger 3 or 4. This is heat exchanger 3. So apparently what happens, this pump does recirculation of the flow and it grabs the heat from the heat exchanger 3. And then the heat is sent out to the HRV1. We also have a 3-way valve right here. This 3-way valve for heat exchanger 3, it modulates to maintain the heat of to maintain the supplier temperature of HRV1. So apparently what happens is if the HRV1 supplier temperature is called for heat, this valve will open more, so we give more heat to heat exchanger 3, and the pump is running at the constant speed. It does the flow to the heating coil to maintain the supplier temperature. Any questions? I know it's for sure.
What's SHR and what's GHR again?
It's okay. I'll
Sorry,
Yeah?
No, I'm just asking the label. Probably just ask their extensions. Okay.
Yeah, this is on the solar side, but here, this side is for the heating HRV1. That's a glycol heat return, glycol heating return, glycol heating supply. Glycol, yeah, because it goes outside, it's gonna be glycol. Yes, so three-way valve modulate to give more heat or less heat to the heat exchanger 3. And that pump will do the flow recirculation, and the flow grabs the heat from heat exchanger 3 to maintain heating HRV supply air temperature.
Okay.
So this does the heat for the HRV.
Yeah.
So this side goes up, the flow. Yes, this is one side. This is the other side.
Only for HRV.
Yes, yes. This side is only for HRV, and this is the pump for HRV. So here, this is a temperature sensor, and this one. So all of them, they are labeled. If you come a little bit closer. So this is the BMS tag for this sensor. This sensor means heat exchanger 3 hot water supply temperature. That's what this sensor is for. If you look at this tag, it means heat exchanger 3 hot water return temperature. If we look at this one, heat exchanger 3 glycol heating return temperature. This pump is a fixed speed. It's a constant speed.
Okay.
So there is no need for the differential pressure because it's not maintaining the differential pressure. And we can see the pump status.
Okay, we can see.
We can see the pump feedback. What is pump feedback? What percentage of the speed the pump is running? We can also command the fan on and off.
Okay.
We can also see fan alarm. No, not the fan, sorry, pump alarm.
Okay.
Pump alarm.
Okay.
Yes, yes. On the BMS, it's very clear
Okay.
which pump it is.
Okay.
Yeah. Let's continue air source heat pump loop. There are 3 pumps that coming from air source heat pump. This is pump 1. This is pump 1. It does air source heat pump 1 loop. It could be heating or cooling. And then we also have a pump 2 and pump 3. Those 2 are controlled by air source heat pump number 2. So one does the heating, the other one does the cooling. So how the loop works is how the pipe is working from the air source heat pump 2. Air source heat pump 1, it comes off pump 1. Then it goes to, we follow the pipe, it goes to, sorry, this is a little bit confused. There, it comes over there. It's probably better if we have a print. But yeah, anyways, that pipe comes off and then it splits to 2 loop, heating loop or the cooling loop. Right now we are in the heating side. If we follow the heating side, it goes all the way to the storage tank 1 and 2. It will be here. Yeah, so this is the storage tank 1 and 2. So air source heat pump 1 is, so storage tank 1 and 2 is collecting all the heat being generated from air source heat pump 1. Storage tank 1 and 2 collect the heat being created by the air source heat pump 1. It transfers the heat to the heat exchanger over there.
Okay.
To the heat exchanger.
We have another heat exchanger.
Yeah, we have another heat exchanger on this side. Heat exchanger 1. So heat exchanger 1 pretty much collect all the heat coming from the storage tank 1 and 2. And then on the load side of the heat exchanger, it goes to those 2 pumps. I believe it's pump 5 and 4.
Yeah.
So this is like the primary loop. And then after that, we have a secondary loop.
Okay.
That is on the other side. Let me see. That's all primary loop. It then goes to the secondary loop in here. And I believe it's pump 7 and 8, hot water. Yeah, sorry, I might need to look at the print. But yes, that's for the primary loop. And then it goes to the secondary loop. Secondary loop, the heat is all coming from the boiler. So it's like combined heat. It's mixing it.
Okay.
So that storage tank 1 and 2 or air source heat pump 1 does the primary heat for the building heating loop.
Okay.
And storage tank 1 and 2 temperature is low. Like air source heat pump 1 is not able to generate enough heat. And then the boiler will turn on. Well, I mean, the boiler is running the whole time, but the boiler set point will increase to provide additional heat to the loop, to the heating loop. So I believe it's 52 degrees. So if the storage tank 1 and 2 temperature drop below 52, the boiler supply water temperature set point will go up, will increase to provide more heat to the loop. The boiler has the high limit, has the internal high limit. As long as the high limit reaches the set point, the boiler will be turned off. Yeah, the boiler will be turned off. Yeah, I can show you the boiler.
That's fire.
Yes, so we have 3 boilers in total. Boiler 1 and boiler 2, they work together. They are running cascade. So they are gas boiler, they will be running together. And this is the boiler 3, that's electric boiler. So on the BMS, you can select which boiler you want to be running at. Which boiler you want to run. You can run boiler 1 and 2, or you could run boiler 3. Yes, and each boiler will have its boiler pump. This is the boiler pump for boiler 3. This is a disconnect, and the VFD is right here. They call it the pump 5. And this is the boiler pump number 2 for this boiler. And this is boiler pump number 1 for this boiler. Yes, they will mix together. No, there was one, but there's a PCN issued that the valve gets removed. So right now it's just based on the pump. If the pump is running, the flow will go through. If the pump is not, it won't go through. Yeah, it's naturally mixing it based on the pump running on and off. Those 2 pumps are controlled by the boiler. So whenever boiler turns on, those pumps will automatically. And this pump is controlled by the BMS. Well, if you don't want to use gas, you probably want to run the electric boiler, right?
Oh.
Yeah, that's the electric. This is the gas. So you have a capability to choose. You want to use the gas boiler or you want to use electric boiler? Yeah, maybe that would be a question for Dirksen. Maybe they can see the energy from here, but I'm not too sure. Maybe I will show you the graphic.
Sure, yes.
Yeah. If you have any question regarding to equipment location, we can look at that. Oh, maybe the solar. Solar is on this side.
Okay.
Hello everyone, welcome to the solar section, domestic hot water solar. And those 2 are the pipe from the solar. One goes return to the solar, the other one is the supply from the solar. If we follow the pipe, it goes all the way to, it comes off pump 17. Yes, so pump 17 shall be running the whole time to do the recirculation for the solar system. And then there is a 3-way valve. So what happens there is whenever the BMS is saying the temperature coming from the solar is too cold, it will start closing the 3-way valve so that we will reuse that heat back to the solar so solar can keep up the temperature. Then we only supply the hot temperature to the domestic hot water system. So let's say at nighttime, the solar is not able to provide enough heat, that 3-way valve will open. So the solar will just do the recirculation mode. Yes, we will heat up the loop. So the heat will return to the solar. So 2 reasons. First is it's more like a solar energy efficiency, right? If solar is not able to provide enough heat, instead of giving the heat to the building, it will take the heat from the building.
Yeah.
So that's why we want that 3-way valve to bypass the cold. A 3-way valve, if we follow the pipe that goes to, it's over there. That's the 3-way valve for the solar system. I believe right now it's closed because of the weather. So no, that is just a key. That's just the key. It's not the indicator. So that is the key. You can manually open and close the valve. This solar is only for the domestic hot water. Only for domestic hot water. So if there's enough heat, it will give the heat to storage tank 3 and 4. That's storage tank 4. This tank will collect all the heat being generated by the solar. The source side of the storage tank 3 and 4
is coming from the solar. That's
The
the
source,
source.
right?
The source, yeah, the source of the heat.
Okay.
It collects the heat, and the load of the domestic hot water is in the of the storage tank 3 and 4 is on the domestic hot water side. Yeah, I think right now we are just looking at the location of each equipment.
Okay.
Yeah, and I will show you the water-to-water heat pump as well. Hey, welcome to the water-to-water heat pump training. And we have 2 water-to-water heat pump training. We have 2 water-to-water heat pump. Water-to-water heat pump number 2, water-to-water heat pump number 1. This is access door if you want to access the control side. And this is the back side of it. It's the 600 volt side. The water-to-water heat pump does the domestic hot water for the building. And the BMS, we will have, on the water-to-water heating side, we will have an isolation valve over there. And another isolation valve there, because if water-to-water heat pump, both water-to-water heat pump are in alarm, and it's not able to provide enough heat to a domestic hot water tank, we will then switch to the boiler loop. So the boiler set point will then increase, then the boiler will be supplying the heat to domestic hot water tank. We have domestic hot water tank 5 to 10. This is for the domestic hot water. And BMS is also monitoring the tank temperature. Our temperature sensor is right here. A storage tank 5 to 10 temperature. Domestic hot water storage tank. No, this is just for the storage. So the heat is coming off the water-to-water heat pump, or if those water-to-water heat pump failed, the heat will be coming off boiler, the primary heating loop. It could be also mixed from the solar panel. So if you don't mind, we can go to the graphic.
Okay.
Looking at the graphic, we'll have better understanding on the system. Welcome to BMS server in the penthouse. This is our BMS server, and this is our control panel. Inside of the control panel, we will have a Jace. So, and the backup battery. Right now, we have a temporary server. This is our computer. We just leave it here so we can do some work. Later on, this will be removed. This is our computer, and this is your server. This is the Jace that does all the communication for the controller, and this thing hosts the graphic. So the communication is through this port, and behind this computer, we have a network switch. So all the IP device, including the penthouse DDC controller, water-to-water heat pump, air source heat pump, they all communicate through this switch. The question I was asked this morning, if we can access the graphic from downstairs office, we can, but not right now, because right now this controller, the Jace and all the control, they are in the local network. So we will have to work with the IT to set up the building network and pull another Cat5 to the secondary port. So that way, the controller is communicating with the building network, and it also gives us the internet access. With internet access, we can set up the email alarm. So there will be email sent to your through text message or to your email address if there's an alarm. Yeah. So yeah, the port is there, it's ready. It's there, it's spare, it can be ready. Well, once we set up we have the building network set up. Yeah. So as of now, we can access the BMS graphic through this computer. Monitor, the server, it's all yours. The login, we have a label on the side of the computer here. The login is HVAC, the password is HVAC1, HVAC1. So the username is HVAC, the password is HVAC1. So this is the main graphic of the DDC, of the BMS system. We will have fan coil unit 1, 2, 3, 4, 5, 6, 7, and the HRV1 up on the roof. Fan 4, which is the garbage zone exhaust fan. We have fan 5, stairwell pressurization fan, electric makeup air unit, EMA in parquet, and we have HRV1. Then we also have hydronic system. We have a heating loop, air source heat pump, a heating plant, air source heat pump, heating loop, cooling loop, domestic hot water system, heat pump loop. And for the miscellaneous system, we have a generator room, mechanical room,
which is in here. Penthouse mechanical room, laundry room. That's the makeup unit. We have a sump pit, 2 sets of sump pit. And we have a summary of the fan coil unit. And then we have the floor plan. Maybe let's start with the floor plan. If we click here, main floor, it tells us where is the location. So on the main floor, we have a fan 4, fan 6 right here. This is the generator room, and this is fan 4, which is the garbage room. Right now, this room is pretty hot because we see the electric heater was on, right? And then here, this is the parquet, electric makeup air unit 1, 2, 3, 4. That's the soffit area, soffit heating, and then we have a fan coil unit 7, fan coil unit 6, and also the EMA 6. Then if we click this button, it will bring us to the second floor. On the second floor, we have EMA 5 and fan coil unit 1, 2, 3, 4. This is the laundry room. That's the dryer and the laundry. Yeah. That's the floor plan. If we look at the graphics for the fan coil unit, let's pick up fan coil unit 1, for example. This is fan coil unit 1. It's on L5 amenity. Here it tells us the schedule. So the fan will only be running in the schedule in occupied hours. In unoccupied hours, it only runs when space temperature is below unoccupied heating set point or above unoccupied cooling set point. So as long we are in occupied mode, the fan should be running the whole time. So the graphic we can see, we can have a fan command, and the fan status. We also have discharger temperature. We also have a heating valve position, cooling valve position. So if I put my mouse over, you see the yellow line or orange line on the side with the box. If you put mouse over, it will highlight background blue. Then we can do a right click. We can override the fan on or override the fan off or leave it auto. Override, it means we force the fan regardless, no matter what. The fan has to stay running. Override it off. If I do off, yes, the fan is now turned off. This is the status, which is the feedback from the fan. This will tell us if the fan is actually running or the fan is actually off. So this is still on. We get this signal from the current sensing relay, CSR. So as long as it's sensing the current, we will see the status is on. So it takes a little bit of time because the fan is slowly ramping down. So we are still seeing the current. Right, so if we do right click, we override, it will ask you, override the duration. Yeah. Right now it's permanent. If you only want to do like 3 hours, you can choose 3 hours. Or you can do custom, 3 hours, 15 minutes, 10 seconds. I don't do okay. Okay, I might need to look at this one because yeah, it might be a little, yeah, there we go. Now the status is now turned off. So I know now the fan is actually, and it also tells us what is the discharger temperature. But you know, the room is still only 18 degrees C. Our set point is 23 and 22. That's why the heating valve is fully open. It's just trying to give the heat to the room. Because some rooms, they are still not finished. The door will be open and closed. So if you click this setting button, that's a setting. Here is a temperature setting. Occupied heating set point is 22. Mm-hmm. Occupied cooling is 23. So that means in occupied hours, when space temperature is below 22, the heating turns on.
Yeah.
This is now changed to 21. So that means if the temperature is in between, it's between 21 and 23,
yeah.
No heating, no cooling.
Yeah.
So only when outside temperature is below this set point, it's, let's see, when space temperature is at 20, the heating will turn on.
Yeah.
Yeah, for all the fan coil unit, the DDC fan coil unit, they all have a thermostat. If you lock the thermostat, we will have, the only way to adjust the set point is from the BMS. So we also have alarm for space high temperature, space low temperature. If the fan not on alarm, fan hand alarm. So fan not on alarm, it means when the command is, but the status is off. So we try to run the fan, but the fan is not running. That's why we have a fan not on alarm. Fan hand on alarm is if you want to turn off the fan, but the fan is still running.
Yeah.
So someone put it in hand mode.
Yeah, that's why we have those two alarm and the space temperature here. Alarm setting. Space temperature high alarm set point is 30. Space temperature low alarm set point is 15. Space temperature alarm delay is 30 seconds. So 30 seconds. So that means when space temperature is above 30 for more than 30 seconds, we would see this alarm. If the space temperature is lower than 15 for more than 30 seconds, we will see this alarm. The perfect example would be this one. See, right now it's the background is showing is red. That means there's alarm occur for fan coil 4. If I click the unit, I see, oh, space load alarm. I see this one is in alarm. Why is that though? Oh, space temperature is only reading 11 C, but our alarm set point is 15. That's why space is too low. That's why we see the alarm. But I know because the discharger temperature is 33 degrees C. So I know its heating valve is open, the fan is running, it does supply the heat to the room. It's just because the room, it has an outsider door. That door is open and closed the whole time. That's why that room is just so cold right now. Once the construction is finished, the door stays closed, the room temperature will be good. Yeah, that's for the fan coil unit. And this is for HRV, ERV, the big ERV in the penthouse we looked at. So it has an outsider damper, and it also has return air damper, return air temperature, return air humidity, and we have a fan status. And on the discharge side, we have a filter, we have a supply fan, and then we have a cooling coil. This might be take a while. Yeah, because I want to go detail with you guys. Maybe another hour?
No, I mean just a little break. Just a little break.
Yeah, like we can do another like 10 minutes break.
10 minute break, 15 minute break.
I want to get some water as well. Hello everyone, welcome back. Let's continue with the HRV on the BMS. So what do we have? We have return air, and then we have return air temperature, return air humidity, and also the damper, isolation damper on the return side. And we have return fan, and the air goes through. Then we have a filter, supply air fan, and then we have a coil. This coil can come from the heating side or from the cooling side. See, right now, this isolation valve, they are closed, so there's no flow going this way. And all the flow comes from this pump. Flow goes to here. Now it's the heating side. Then heat exchanger 3. This is a 3-way valve that modulates to maintain supply air temperature. So supply air temperature set point is 22. Now it's maintained pretty well at 23. So this temperature is above the set point. So that's why the valve is already fully closed. Once this temperature drops below 22, this valve will start opening again. On here, we also monitor the supply temperature and the return temperature on the heating coil. And downstream of the coil, we have a low limit and the supplier temperature sensor, and also the isolation damper. After that, we have a smoke alarm that is being fed from a fire alarm panel. Then we also have full baseboard heater. The baseboard heater from 19th floor to 20th floor, that's the command on here. And from 3rd floor to 18th floor baseboard heater, the command is right here. To control the HRV BMS, we will have the enable, heat recovery mode, recirculation mode, low alarm, and the damper alarm. All those signals we pick up from the ERV panel I showed you earlier. And from the configuration page, we have some temperature setting. So let's say in the summer mode or in the heating mode, we have a supplier heating temperature set point, which is 22. But in the summer, we will be the cooling set point will be 18. So apparently in the summer, the heating isolation valve will be closed, and the cooling isolation valve will open. Once cooling isolation valve opens, this cooling control valve will modulate to maintain this temperature at 18 degrees C. And then here, heating cooling mode switchover set point. That is the set point for the ERV to switch between heating mode and cooling mode. It also based on the building mode, right? Because the building can also be in heating mode or in the cooling mode. Then we will have economizer mode. As of now, economizer mode is disabled. In order to enable the economizer mode, in order to enable this, all those conditions has to be true. So as of now,
the return air enthalpy is greater than outside air enthalpy, which is good. This is the check. Outside air temperature has to be lower than economizer enable outside air temperature, which is good. This is also a check. But we want outside air dew point. We want this to be higher than 20. So right now the outside air dew point is too cold. That's why this is disabled. And the supplier temperature has to be greater than 8. This is also good. So in order to go to economizer mode, the outside air dew point has to be greater than 20. So that is more like in the shoulder season. Outside air temperature will be able to free cool. Will be able to do the free cooling. And here is some PID setting that we don't want to touch because as of now the PID setting is pretty well. It's maintained pretty well. And we have pump 30. It's the constant speed, so it's just 40%. As long there is a call for heating, this pump 30 will always be running at 40%. Other than that, there will be just some alarm settings that BMS use. Supply air temperature low limit set point. As long as the supplier temperature is below 8, we will disable the alarm. We will disable the unit because we don't want to bring too much cold air to the building to freeze the building. Yeah. And then the delay to trigger the alarm and outside air damper delay. So apparently what that means is when damper opens but the status is still closed, after 60 seconds we will see the damper failure alarm. And also we have fan, supply fan fail alarm, return fan fail alarm, supplier hand temperature offset alarm, supplier temperature low alarm, supplier temperature low delay, and the filter. So filter alarm is 0.5 inch water column. That's for the filter. If the filter dirty, then we will see out here, we will see alarm. Right now it's 0.4. We see outside it's kind of close to the point. And here is a trend. I click, I can see the trend for this pressure sensor. That's a trend for today. It's going up and down because the internal damper was switching as well. That's why this pressure wasn't stable at one point. But if I look year to date, I can see the differential pressure is getting close. It's increasing. Yeah, this temperature is going up and down. It's just because the internal damper was switching. That's why it affected this pressure, differential pressure on the filter. No, remember, because right now we are in the heat recirculation mode, the ERV, internal damper, will switch every 60 seconds. While that damper is switching, it affects the flow rate because when that damper is closing, suddenly we will see this drop a little bit, right? And then once that opens, we will see pressure go up again. Yeah, you can use that to tell the damper is working or not as well, yeah. And also if the damper failed, we will see a damper alarm on here. We will see the alarm. Okay, so switch between heating and cooling, it will be on the main page here, building changeover. Right, so right now it's heat, is the winter mode. So if we click this button, it will say changeover mode. Right now it's winter. And then winter enable set point is 15. Summer enable set point is 18. Winter mode changeover delay is 2 hours. Summer is 12 hours. What that means is if the outside air temperature is below 15 degrees for more than 2 hours, we will be in the winter mode.
Winter mode. Okay,
Yeah.
so 15.
Yeah, if outside air temperature ever goes past 18 degrees for more than 12 hours, we will switch to the summer mode. Yes, so on here, the setting, you can always come to the setting page. 22 too hot, we can set.
Yeah.
No, you can increase, you can make this to 40 if you want. Because the heat is not only being recovered, right? This heating coil, this coil also does the heating. So, yeah, this can go up to 50 degrees, I would say, 50. So right now, if we follow the piping, this valve is closed. So they come from this heat exchanger, right?
Okay.
The heat exchanger 3, if we click here, come and heating loop, if we click that, it brings us to here, right?
Okay.
This pipe goes to the HRV, and then they will be coming from here, pump 8 and 9,
Okay.
right? And then there's another 3-way valve. This 3-way valve maintains this temperature at this set point.
So, and then this is coming from here, heating system. We click that again. That's the heating loop. So, yeah, we have the boiler going to the loop, flow through this, then go back to the heating loop, right? And because those valves are also open, this pump is also running. So what happens is the flow will be come back and then go back here to the boiler and come back. Then flow goes to the heat exchanger and then through the pump, then flow. So right now there's no flow going through here pretty much. But when those two pumps are turned off, when this pump are turned off, flow will go through here. There's no flow going to here.
Okay.
Only if the pump are off. If the pump are on, the flow will have to go through this heat exchanger one. Yeah, that's why I call this secondary, primary, secondary. Yes, but this one will be running the whole time as well, just because we want to collect as much heat from the air source as possible, right? We want air source to be doing the main job and the boiler to do like additional. More like
What is the electric boiler there?
this is electric boiler.
boiler.
Yeah, boiler 3. 1 and 2, they are gas boiler. Cascade control. So boiler lead select. Right now it's boiler 1 and boiler 2. I can switch to boiler 3. Then it will be boiler 3. Yeah, but right now I want the boiler 1, boiler 2 to be running because I need to work on this VFD a little bit. The boiler supply temperature, boiler return temperature. Yeah, but they are on the common line, not the individual boiler, but the common.
line.
Yeah, outside temperature is here. It's -8. Cut. That's for the ERV. For the hydronic system, let's start with the air source heat pump because this is the primary heat where the heat is coming from. So we have air source heat pump 1, right? And the pump 1 does the flow for the air source heat pump 1. So how that works is it's on the return side and the supply heating. Right now this is closed. Heat, okay. So this is the air source heat pump 1 heating valve and the cooling valve, okay? So right now we are in the heating mode. So the flow pump goes to air source heat pump 1. It doesn't go down because the below is the cooling side. So the cooling valve is just closed. It's just capped on here. So flow just goes through here. And here we have a T. This T will be coming from pump 2, which is the heating side of the air source heat pump 2. So apparently like this will be a flow going to here. The heat pump 2 will also have a flow. Like they mix up together. Air source heat pump 1 heating and the cooling heating side. They mix up together and then expansion tank, the glycol fuel tank, and then go to storage tank 1 and 2, right? That's for the heating side. And if you are looking at the cooling side, in the cooling mode, this valve will be closed, this valve will open. So air source heat pump 1, flow goes this way, it doesn't go here, it's capped. And then there is another T, it mixes up with air source heat pump 2, cooling side. This is on the cooling side. And the cooling side, they mix up together here and then they go to the cooling loop. They go to this pump. Yeah. So this one can do heating or cooling. You can only pick one. It's just based on the cooling building mode. And then this one will do the heating as well as the cooling together. Yeah. So, sorry. Let's see, right now it's in the winter. The only heating source is coming from here. The heating source is from here, and also the heating from air source heat pump 2. That's the heating. And the cooling side, it will be air source heat pump 2 cooling only. So this one won't do cooling. This is capped. This is just closed. Yeah. So heating will have 2 sources. Cooling is just 1 source. If in the summer, cooling will have 2 sources. Heating will be 1 source. Air source heat pump 2 is always doing heating and cooling together.
Okay.
Right? So that regardless, air source heat pump 1 is doing heating or it's doing the cooling, air source heat pump 2 is always doing the cooling and the heating at the same time. And it's just in the winter, this gives extra heat. In the summer, this gives you extra cooling.
So that one's like main.
Yes, it's always the heating and the cooling together. Air source heat pump 2 is always, because it collects the heat from the cooling loop and dump to the heating loop. It's just so efficient. Yes, so all the suite fan coil unit have its own heating loop and the cooling loop.
Okay.
Individual. So as of now, you see some alarm for the pump 3 and the pump 10 and 11 because we are still working on we are adding another storage tank on the cooling loop. So this loop is empty. So we turned off the disconnect of VFD because we don't want VFD run dry. Yeah. Air source pump, heat pump 2 is not yet. Not yet. We will do the startup in the summer. Air source heat pump 1 is running, yeah. It depends on the building mode.
Okay.
If it's in the winter mode, if this valve is open, right, this cold air, the cold glycol will go to the storage tank and it will collect the heat from the storage tank and then send back to the solar, which is not energy efficient. So right now the solar system is pretty much, I would say, disabled right now because of the weather. When this storage tank temperature is low, we will disable this pump 25. So we don't want any heat recirculating in here. Because then what this does, it will grab the heat from domestic hot water, right? Right now we want this temperature to be 60, then we will enable this. So we know we always give 60 degrees C energy to the heat exchanger. Then domestic hot water return, okay, 60, then it grabs the heat, then go back to the domestic hot water tank. Go back to the storage tank. That's for the solar side. And this is domestic storage tank for domestic hot water. We have a mixing valve. This is the mechanical mixing valve. Domestic hot water tanker supply. And the storage tank temperature. The heat of the storage tank number 5 to number 10 is coming from this loop. See, right now this is a high heating loop bypass. So right now it's bypassed, right now it's closed. Pretty much this is capped. So all the heat from the storage tank is coming from water-to-water heat pump. So what that does is, the boiler loop temperature is only 56, right? It's only 53. It's only 52.6. But we want this temperature to be at 60. So the boiler loop is not capable to provide enough heat to storage tank 5 to 10. That's why we have this bypass valve closed. Right now, all the heat is coming from the water-to-water heat pump. So water-to-water heat pump supply water temperature is 61, right? It does the heat. The pump 14 is turned on. The heat is now dumped to storage tank 5 to 10, and then the water return to the water-to-water heat pump. So water-to-water heat pump it's like boosting, right? Because the boiler loop temperature is only 53, 52. We want this to be at 60. So water-to-water heat pump does the boosting up for the temperature. And this is the heating side of the water-to-water heat pump. This is the cooling side of the water-to-water heat pump. What it does is when compressor of water-to-water heat pump compressor is on, the heating side temperature will go up, but the cooling side temperature will go low. We don't want this temperature to go too low. Otherwise, this will be underperforming as well. So we always want the cooling side temperature to maintain well at 34 degrees. So what it does is when this temperature is below 43, let's say this dropped to 30, let's say this dropped to 30 degrees, it's below the set point, we are then start opening this three-way valve. So we want some heat from the heating loop to warm up this temperature. So yeah, so most of the time you will see water-to-water heat pump is on, this temperature is maintained at 34. If it's below 34, this valve will open. See, right now it's 100%. It means 100% from common to B. So common to B, this is 100%. So the pump is running, it's just doing the recirculating in here. Just bypass it because the temperature is already happy, right? If temperature is low, we want a little bit more heat from this loop, then go back a little bit and do some. Yes, 100% means 100% from common to B because this hydraulic loop has so many three-way valves, it may get confused how it's open, how it's closed. So that's why we always label which one is A, which one is B, which is common. and all the percentage will say, okay, 100% common to B. Common to B, this is 100% flow. This is 100% flow. So if it's 0%, it means 0% common to B. Common to B is 0%, so it's full flow. Yes, so it's turn off, but it's turn off, but not turn off. So what I mean by that is the pump is still running, but the three-way valve is 100% closed because the solar is not generating enough heat for those storage tanks. That's why this 100% common to B, this is 100%. The pump is running, it's just doing the recirculating. Because the temperature we want for the storage tank, the temperature we want is 60. We want 60. But solar it's not capable to produce that much heat because of the weather. And it's not sunny. There's not enough sunlight. Otherwise, the solar will steal heat from the storage tank and then bring the heat to outside, which is the waste of energy. Yeah, that's for the hydronic loop on the heating side. The pressure will be on the heating loop and the cooling loop. On the heating loop, we have two pumps, right? We have a supply pressure, return pressure. The differential pressure is a 31.9 psi. So right now the pump 9 is almost running full speed to maintain this pressure. Yes, that's a differential pressure, yeah.
Okay.
Here is a trend. If you look at the trend, month to date, we can see it here. It's maintained pretty well. This is 32 to 30, right? There's a little bit spike, but it's good. Yeah, and this temperature, very good. The other thing I want to mention about the domestic hot water. So if there's an issue with water-to-water heat pump, if there's an issue, if both of them are in alarm because it's not capable of doing its job, this valve will close, this valve will open. We are now bringing the heat from the boiler to storage tank because right now the boiler temperature is too low, it's only 53, right? As soon as those two water-to-water heat pump failed, the boiler supply water temperature will increase to 62 degrees C. So that means the boiler loop will take care of the domestic hot water. The reason we don't want the boiler to do the job because for energy saving, right? For energy saving. So we don't want that. So as long as the boiler loop can do 52, we are happy. And that's also one of the reason we have this three-way valve in place. Right now, the boiler loop temperature is only 53. If the water-to-water heat pump failed, the boiler supply water temperature set point will increase, right? But increase to 62 degrees C. But we don't want the 62 degrees C go to the fan coil unit. That's too hot. Then we have this three-way valve. So we always want to maintain this temperature at 52 degrees C. Yeah, that's for the heating side. The cooling side, we can go over a little bit as well. It's cooling side is a pretty simple one. It's less complicated. It's just heating. It's coming from the air source heat pump 2 and in the summer mode from air source heat pump 1. Then they go to these two pumps. We have differential pressure sensor. We will measure the differential pressure and we will run those pumps at a certain speed to maintain the differential pressure at set point. We also have supply temperature, return temperature. They directly go to the fan coil loop, I believe. So from the air source heat pump 1 and 2, the cooling loop, it goes to the ERV or it goes to this heat exchanger. Heat exchanger 2, and heat exchanger 2 will have the heating. So air source heat pump 1, 2 gives the heating to heat exchanger 2, then heat exchanger 2 will do the recirculation. So this loop goes to the fan coil unit, the sweet fan coil unit downstairs. Oh, and here, differential pressure. I believe the other pump, those two pumps, they are just at the fixed speed. Fixed speed, yeah. Because it's actually a closed loop, right? It's a closed loop. We have 4 heat exchangers in total. Yeah.
Okay.
So heat exchanger 2 is for the cooling.
Okay.
And then we have heat exchanger 1 on here.
That's for the heating.
For the heating, main loop. And then we have heat exchanger 3 and 4.
Okay.
Yeah. 4 is for the solar or domestic hot water. 3 is for HRV, ERV, yeah. Yeah, heat pump loop. We also have heat pump loop, heat pump in electrical room, right? There are two valves for the heating, 2 valves for the cooling. If it's in winter mode, we will, in the winter mode, right now I override to the heating because I was doing the test. And also this pump failed. We are just waiting for the part, to replacement for this pump. So this 3-way valve will modulate to maintain this return temperature at the 30. So we'll always want this to be at the 30. So this heat pump will be performing. Then other than that, we have a garbage drum exhaust fan 4. So we monitor the space temperature. We have exhaust fan. We have damper, right? When outside temperature is below 5, we will turn this off. That's why it's off, because it's too cold. And there is also minimum off time for the fan. And we want to close the damper 30 seconds after the fan. We always want to turn off the fan first before we close the damper. That's for garbage room. When outside temperature below 5. Below 5, but it's adjustable, right?
Yeah.
So right now, for example, right now -10, right? I can change this to -20. If I change this to -20, I should see this open. And then I should see this fan. See, then now it's open. Fan didn't open because the switch didn't make. We are waiting for the end switch to make. Like 90 seconds, I believe.
90 seconds.
Yeah, always lower the set point as well.
Lower.
Yeah, that's for garbage room. And then this is vestibule, fan 5. Vestibule pressurization fan. It's just running the whole time. We have fan status, we monitor the fan command, fan status, and HRV1 damper with the control the damper, and the HRV enable, disable. EMA, electric makeup air unit for the sulfate. See, 1, 2, they share one space temperature. 3, 4, they share one space temperature. The set point for the space temperature is 18. It's 18 for all of them. See, right now, the EMA 6 is turned off because we see the temperature is happy. So it's turned off. Those are still saying the temperature is cold. That's why they are still running. Same with 5. 5, same temperature, a little bit low. That's why we have this fan. We kept this running. And if the space temperature is low, it's too low, we will also see the alarm. Gone through the ventilation system, okay, miscellaneous system. The generator room. Generator room, we have generator room exhaust fan 4. And we also monitor the room space temperature, the generator status. We also have the recirculation air damper, the outside damper, recirculation air. We also have combustion air damper. So the sequence for the generator room is this fan stays running the whole time, no matter what. If this fan is turned off, if we don't see the air-proofing switch, you will see alarm on the fire alarm panel. On the fire alarm panel, you will see alarm. Yeah, and this 3 damper, when generator is turned on, all those damper will open, fully open for 30 seconds. And then after 30 seconds, this damper will be modulating to maintain the space temperature. Because generator creates so much heat, we will need to reject the heat. And the space temperature is 22. As soon as a generator is running, the temperature is above 22. The outside damper, exhausted damper will open, the recirculation damper will close. So right now, this damper is closed, this is closed, this is open. Those two, the interlock. While this is opening, this will close. Yeah, when this open together. Those two open together, this one interlock with those two. And when this is running, combustion air damper also opens and it needs to stay open. According to spec, there are 3 levels. Level 1 is a CO level 1 is a 25. NO2 level 1 is 0.7. That means if the CO level goes above 25 or goes below 0.7, we will see high level 1 alarm. We will see this alarm. Level 2, we will see this alarm. Level 1 alarm, this 2 damper opens, this damper close. We are purging the room. Just purging. If we are in level 2 or level 3, that audible alarm will trigger in the electrical room, and also the BMS will also see it. It will also show on BMS. And we stay the purge mode. It will still try to purge the room. It doesn't matter if it's a full load or no load, as long as the generator is running, the damper will operating.
You should expect them to open.
Yeah.
Okay.
Yeah.
Okay.
But only for the first 30 seconds. It fully open, and then it gradually open, close, depending on the room temperature. Right? Also depending on how much you are running the generator. You are leaving this running for an hour, the room will be hot, right? They will just open to reject the heat. Yeah. This is actually where we are. It's in here. Maybe let me finish this. I will show you where these things are. We have two fans, fan 3 and fan 7. Fan 3 will turn on to reject the heat. For example, let's say the average of those two, when any of those space temperature exists at 26, right? The fan, exhaust fan will turn on. Also the return air damper, mixed air damper, they will also modulate because to reject the heat to the room. The heating set point is 15. If this temperature drop below 15, this unit heater will turn on. Yeah, if it's above 26, the fan will turn, mixer outside damper will open to reject the heat. So unit heater is for the heating, this is for the cooling. No. So BMS controls the unit heater for those 4 unit heater. You can turn it off from the breaker or you can turn it off from the BMS as well. On the BMS, we can also turn it off.
Because I noticed on the older building.
I see. No, not for this system. For this system, if the fan failed, it will show orange. Or if the temperature failed, it will show 0, and it will be reading 0, and it will show orange. Oh, maybe they bind it to the command, not the status. So the BMS, for example, there are command and the status, just for like the fan, just like this fan. We have enable, we also have the status, right? Status is the feedback tells you the fan is actually running or it's not. So maybe in your scenario, they don't have the feedback. They only have a command. So just the BMS is trying to run the fan, but BMS doesn't know if the fan is actually running or not. Maybe that's the case. Yeah, mechanical room ventilation, unit heater for the heating part. The exhaust fan will be for the cooling. No, not in here. No. Laundry room, makeup air unit. This is the makeup air unit in the laundry room. The unit location is actually in the bike room, but it serves to the laundry room. Because laundry room has 2 parts, right? We have Planium 1, Planium 2. That's why the ductwork gets split. The bike room or makeup air unit room, it has a fire damper. The fire damper needs to stay open the whole time for combustion air because we have a gas burner in the room. So fire dampers has to stay open the whole time. As long as we see the fire damper is closed, we won't run this unit. We won't run this unit. Yeah. But it stays open the whole time. And then makeup air unit, we have outside damper. This is our BMS damper. We will control the damper. Those 2 damper, it's internal. It's the unit internal damper. So this damper needs to fully open before they turn on the fan. It's just package unit. It comes with the unit. And then we have outside temperature sensor from the unit. Then we also have a filter. Monitor the filter differential pressure. And there's electric heater. After electric heater, we have a supplier temperature. This unit heater turns on to maintain this temperature at set point. Then we have a cooling valve in the summer. This opens to provide heating. And then we have a fan, then we have a gas burner, then we have a bypass as well. Like I mentioned earlier, this fan speed is a fixed speed, doesn't have a VFD. But how are we maintaining the space temperature is based on this, right? That's the case if we only have 1 dryer running, right? Less likely we only need little air to the space. If we have all the dryers running, bypass will close, full fresh air to the space. As long as the Planium temperature is maintained well at 0 degrees. Yeah. The set point space pressure, these are the space pressure. Right now they are in slightly negative, and 2 space pressure, space temperature sensor. Maybe I will show you here. The space pressure. So the unit is actually maintaining the supply air temperature, right? But supply air temperature set point is being calculated based on the space pressure demand, space temperature demand. What that means is it takes the average space temperature and supply air temperature will have a minimum set point and maximum air set point. So that means if the space is too cold, supply air temperature will not go to 37.7 immediately. It goes gradually, slowly. Because once the space temperature is satisfied, it stops at that set point. If the space temperature is too hot, it goes down. Set point goes down. But it will not go exist at 12 degrees C. It also will not exist at 37. For efficient operation, this is what I was told by engineer, like the unit supplier. Because we have electric heater and gas heater, we always want to use electric heater as a first stage. So most likely we always want to run this one instead of this one. So there is outside air temperature. So gas burner enable outside air temperature set point is -20. That means if the outside air temperature is above -20, let's say today is only -10, the gas burner is just disabled. There's no need. There's no need for that. Just electric heater is enough. But in the extreme cold weather, outside temperature is below -20, we will enable this. This is just like to provide additional heat in case this is not capable of for that much heat. And also those two, the cooling valve and the gas heating, they are working based on the set point. So it's a package control. It automatically adjusts to maintain supply temperature at set point. Sump pit. So there are two sump pit. We monitor the high level and the fault. This one is normal. It means it's powered. This one, high level is okay. Level is okay, but fault. So that means there's something wrong with the sump pit. And I believe this sump pit was just not powered. When that is not powered, we also see the fault in here. I believe it's just not powered. So if I go there, I turn on the disconnect, this will go back to normal. I can do that.
Yeah.
I can
It
do
would just be easier for us to identify it.
bike room. I would just say bike room, garbage room. Okay, I would say bike room, sump pit.
Yeah.
Okay, I'll make that change.
Okay, thank you.
Sump pit, I'll write that down.
So at least we would know.
It just based on the building mode. If it's in heating mode, turns on. Cooling mode, turns off. No, the BMS will only turn it on, turn it off. That's it. Yeah.
Oh,
So you can just turn it off or turn it on.
with the basic word. Okay.
From 3rd floor to 18th floor, that's one command.
So indeed, okay.
From 19th floor to 21st floor, that's another command. And now here we also have sump pit high level and the BTU meter. If you click here, so see fan coil unit 6, we have a BTU. What's the flow rate and the energy use, temperature, energy rate peak for the BTU. Same thing for the energy use. No, we don't have integration with energy meter, but we can monitor. Are you talking like BTU energy use? RMA? Yeah, for this one, no, there's no annual fee. Well, it's always recommended because that will keep us the most up-to-date feature and also will fix some bug from the previous version. It's always, but it's not mandatory.
It's not mandatory.
Yeah, so, yeah, and right now you can access the graphic from the web, but you cannot access, what do you call that? Programming. You cannot, so apparently right now, you don't have a software. You don't have software, just the web. It's just the web. There's
So
no.
web is all.
You can turn this. You can still turn it.
Okay.
You're just not able to change the program.
Okay.
Yeah. So as of now, it's on local.
Just
That
on
means
it.
you have to be on here.
Okay.
But if you can coordinate it with your IT to give us the internet access. So your IT needs to run another cable and they can plug to this port. Then your IT tell us what is the IP address we should set up for our device. Then we will change the IP address for our device here. And we have to make sure we have the internet access as well. So I can set up the email alarm. That's one thing. And then you can request the remote access. Let's say you are at home, right? You can request your IT to give you set up the remote access. Well, first we have to have the internet access for sure, right? Yeah, once you get internet access, we will have to ask your IT how they want to set up the remote access. There are two options. We can set up the remote access as well by doing the port forwarding, but most IT doesn't like it, to be honest with you, because of for the security reason, they wouldn't recommend to do the port forwarding. And if that's the case, your IT needs to provide internet remote access. Maybe they can need to do the VPN or something. Yeah, that's something we have to work with IT to see how we can get this internet access and to do remote access. And then the other way to make it easier, so you don't have to access the graphic from home. You can access in the building. As long you are connected to the building network, you tap IP address, you will access the graphic. Yeah, but still, we need to coordinate with the IT to see how they want to set up the network. That'll work too. It's more like it's more like how IT department wants to manage their network, right? Some building they will just put a router here, just easier. That's the most easy way, and yeah. But some IT would prefer to manage the network through their switch.
Okay.
Yeah, like in downstairs, because for the security reason, right? And also through that will be easier to set up a remote access. Yeah, as long you are connecting to this building network, you can access.
Okay.
For sure. So there are two ways to access Trend. There's an easy way too. So like user friendly. You come here. There's a button. You see the little square with the Trend stand. Like for example, this temperature. If I click it, the window pops up, right? It gives you the trend. You can change. You can select last 7 days. What's the trend for last 7? Oh wow, it's maintained pretty well, right? Year to date. So one thing to be aware is we only have a trend for 2 weeks. Yeah, that's for this system because we only have a JIS. It has a limited memory. We don't have the software. If we have a software, like the supervisor station, we will have permanent trend. But because of the system setup, we only have a 2 weeks trend. For example, if you want the trend, this is for trend log.
Yeah.
For example, if I do, so we have pump 4, supply water temperature, return water temperature, speed, right? And I just by clicking it, it will automatically add on here. Then close it. I go build. Here's time of range. I want to do last month or month to date. I go build. Here's the trend. The blue is the supply water temperature. The green means it's a return water temperature. This purple means pump speed. So right now, pump speed is at what? So I think right now we got the data here and explore. Table can do CSA, CSV, or PDF. Oops, where did I save it? Oh, now it's exporting the data. It's downloading. We'll see how it looks like. No, this doesn't look good, right?
Yeah.
So maybe we will do CSV file.
Okay.
Yeah, it's not licensed. Okay, yeah, anyways, but here, no, it doesn't have a Microsoft. So, but here, you can copy the file to the USB stick, and then you can open the data from your phone, or from a different computer. It will tell you at what time. Well, what do you have to do? You have to select which trend you want to export, right?
Yeah, that's right.
So you have to select, oh, okay, that, which one? And then you have to build. Then you have to build it. Oh, the other thing I might want to show you is schedule. This is the schedule ERV schedule, we want it 24/7, right? We want to be running 24/7. Let's say fan coil 4, if you don't want them to run in 24/7, if you want Friday to be turned off, you can just click here, false. And click here, false.
I'll just put false.
And if you want to change the time range,
Yeah.
you can just drag it. Right, on here you can also drag another one, make this false.
Yeah.
Yeah, and after that you click save, it's saved.
Oh.
Yeah, that's how you change. That's how you change the schedule. You don't need to change the schedule for the pump, because what happens is for pump is I will show you. For example, right now pump 5 is running, pump 4 is not, right? Pump 5 is running, pump 4 is off. If I go to config, right now the pump 4 and 5 they will switch based on the runtime. So once it is running for a week, 168 hours, they will switch. So right now it's pump 5, or there is another way, a manual switch. So if I click here, do a simple click, 5 is running, 4 is off, right? They will switch, automatically switch. It's recording at the background.
The background.
Yeah, but you can tell, you can change how many hours. The other thing we can try, see now it switched to pump 4. Oh, if you notice they didn't switch properly, yeah, you can call us, but I already tested them, they are working. So for the domestic hot water, we have a domestic hot water. For the cold water, there must be one. I think, I'm pretty sure there was one, but it's not on the BMS. So
ask them.
yes, yeah, it might be a question for